In Trellis, the ability to interact and select items in your model is an important factor for getting through the meshing workflow. Particularly if you have a large model or assembly, this task can sometimes be difficult. If you have lots of surfaces and you're trying to select just a few, or many curves and you're only trying to select one or two that have a particular characteristic, it can at times be difficult to find that exact one. Now, one of the strengths of Trellis is that it has the ability to extend functionality via Python. We have a mechanism in Trellis called extended selection or extended picking. To help demonstrate, I'm going to import a model that has a lot of pieces to it. It's a model of a brake disc for a car. And you can see here that it has the disc and the actual brake part, lots of nuts and bolts, lots of different pieces to this assembly. And if I'm looking for a particular one, it could be difficult to select them. So to use the extended selection capability, you have to start out with an initial selection that you want to filter out. So what I'm going to do is select volumes, and I'm going to use the box select to select all of the volumes in my model. Then I'm going to right click, and in the context menu here there's an item called Pick Extended. So we'll go ahead and click on that, and you can see here in the extended selection dialog, right now we don't have any of our selection filters loaded. But over in our source selection column we can see the list of all the volumes that were selected in the graphics view. So to load filters, we'll click on this button, and it wants to know a directory where I've put all of my Python filters. So I'm going to leave it as is because this is where my filters are. You can see it automatically found all of these filters. Trellis is looking for Python scripts in particular, and it will list them here. And it has a nice summary of what's in the script down here, so you can double check to make sure that those are indeed the filters that you want. And you can individually select filters if you don't want to load all of them. For this tutorial, we're going to go ahead and select everything. So I press OK, and that loads all the filters. Now when we come back to our dialog, you can see that in the combo box here, it is now populated with all the names of all the filters. I can look for adjacent volumes, I can pick curves or surfaces, based on these filters that we have defined on Python. So as an example of this, let's go ahead and say we want to pick all of the surfaces in a particular volume. Choose the Pick Surfaces item in the combo box. Once we've done that, if we click on one of these volumes, you'll see that in the target entity column here, it will populate the list with all of the surfaces that belong to this particular volume. And indeed, if I click on it, on the surfaces, you can see it only has the surfaces related to that volume. If I want to select all of them at once and have it highlighted in the graphics view, I can right click and use the context menu for the target entities and click Select All, which will then highlight all of the surfaces that belong to this one volume. One of the nice features about the extended selection dialog is that I can drag entities in between columns. So if I've narrowed it down to this particular surface on my volume that I'm interested in, I can drag that now over to my source selection, and it brought it down to the bottom of the list, and I can select that to do further filtering. So for example, if now I want to pick the curves that are just on that one surface, I can select just that one surface, and indeed there are the curves for just that one surface. And so if I want to remove everything else from my list here, I can do a multi-select. I'll press the Shift key on the keyboard and select the top of this list so that everything is selected. And I can right click on the source selection side and say Remove Selection. And as you can see, all of the selected entities in there were removed, and I'm left just with this one surface that I was interested in. And now I can go back into my filters and choose other things if I want. Another important feature to keep in mind with the extended selection dialog, particularly with the target entities column, is that you can select them, and in the context menu you have options to remove particular selections like we did in the source surface, but even more importantly, you have the option to copy either the names of the entities to the system clipboard or copy IDs to the clipboard. We will go ahead and copy the IDs in this particular case. And what that means is that now down here, I can type in, for example, curve, and because it's copied the IDs, I can paste the IDs right there on the command line. Or if I'm over in a command panel and I'm working on perhaps curves and I'm modifying them, I can paste them into this pick widget so that I'm using only these IDs for a particular operation. So now that we know how to use our selection filters, let's go ahead and create one. To do that, I'm going to go ahead and close our extended selection dialog, and I'm going to bring up another program called Qt Creator. Qt Creator is a C++ IDE, but we're going to go ahead and use it because it has a nice text editor in it, and also because it has the ability to create Qt UI files, which will be important to add user interface elements to the extended selection dialog. So to start, I'm going to go ahead and create a new file here, and I'm just going to call it a simple text file, and we will call this myfilter.py. The .py extension is important because that's how we will recognize that it's a Python script, and I will go ahead and save it in the same place as all of my other filters right here. Say next and finish. So now I've got a Python file. Now there are a few things that we need to do to be able to implement our own selection filter. The first thing that we need to do, we need to import our GUI module. We're going to import Cubit GUI, which contains our selection filter class. We're also going to go ahead and import Cubit so that we can interact with the core Cubit library and get useful information about entities. So we will go ahead and define our Python class. I'm going to go ahead and call it myFilter, and this is important because the name of the class actually needs to match the name of the file so that when we're loading the Python file we can go ahead and instantiate the class at runtime without any additional information from the user. So be sure to name your class the same as your file. In this case, my file name is myfilter.py and my class name is myFilter. And the way we do inheritance in Python is we just enclose the name of the class that we're inheriting in parentheses. So we're going to type in cubitgui.selectionFilter. Just like this. And we'll go ahead and define this class. The first function that we will re-implement in our class is the displayName function. So we set up our function definition, and this is going to return the text that will be displayed in that combo box that we saw on the extended selection filter. We're going to go ahead and be simple and just call this myFilter. The second function that we are going to re-implement is called runFilter. This function gets called whenever an entity is selected in that source selection column. So if I go back to Trellis and, for example, I select this volume here, go to Pick Extended, you can see over here in the source selection column, whenever I click on something in here or the selection in this source list changes, the runFilter method in our Python script will be called. So going back to our Python script, this is where the actual filtering happens. When we run our filter, we want to go ahead and clear out all of our target selections from the list so that we always have a clean list of things on the other side. You don't have to do that, but that's what we're going to do. One thing we want to do to filter out our enemies is to filter it by the entity name. And so we will go ahead and create a filter to do just that. To start out with, we will go ahead and get the entity types from our base class by calling self.getSourceTypes. This function will return a list of all of the entity types in our source selection list that we saw in here. Again, bringing up this dialog. Right now, what we have is a volume, and we've only got one item in there. And so that list of source types is going to have, we expect it in this instance to have one item named volume. We can also get the IDs of all the entities in our source list by calling the getSourceIDs function. Now we've got our types and our IDs. We have to do something with it. We're going to iterate through these parallel lists and say for our type and our ID, I'm going to name this a little better, in our source types and our source IDs, just like this, we're going to check if the entity name, well actually first we'll get our entity name from Cubit, and this is why we imported the Cubit module. We're going to call Cubit.getEntityName for our type and ID. Actually, I'm going to rename this again to be a little more descriptive, our source type. Source type and ID. And then we're going to check if the entity name has a particular substring. In this case, I want to see if hex is in the name of the entity somewhere. In this particular model, because I'm familiar with it, I do know that there are entities like this volume here that represents the bolt or the hex nut. But hex is in the name of this volume, and so I want to look for all the volumes that have hex in their name and filter those out. So coming back here, we're going to use the Python way of determining if a substring is in another string. It's really easy. We just say if hex in entity name. And if it is in our entity name, we will go ahead and we will add this to our target selection. And we'll say, tell it what the type and the ID of our target selection is. And when we add it to our target selection, it will then populate on the right column of our dialog the target entity. That's our script. Let's go ahead and save that. And we'll come over here, we'll go ahead and select everything again. We will go to Pick Extended. You'll notice that our filter is not yet in this list of filters, so we will go ahead and call Load Filters again, and we will select everything again, but this time you'll notice that my filter, which we just wrote, is in our list of filters. We'll press OK, and we can see I can now select my filter. So if I go ahead and select everything in this list, I'm going to use the keyboard shortcut Control-A to select everything in that list. That out of all of those volumes in our source selection, it successfully filtered out everything except for the volumes that had hex in their name. And so we can quickly find out all of the entities named hex. So that's pretty useful, but it is a little inconvenient that we have limited ourselves in our filter to finding entities that only contain the word hex in their name. It's not very generic and cannot be applied in many different situations, because maybe next time I want to look for something called nut, and it would be annoying to go back to our script, change it from hex to nut, and then reload our script just to change that. So what we're going to do to fix this problem is we're going to add some user interface elements to our extended picking dialog. To do that, we need to re-implement another function in our selection filter base class. Got to make sure the indentation is correct in our Python script. And this function is called getUIFile. Now this function is supposed to return the path to a particular UI file, a particular Qt UI file that defines our user interface elements. I'm going to cheat a little bit and use a nifty Python trick so that I can define my UI file to be in the same location as my Python script that we're using right now. And to do that, I'm going to need to import another module. I'm going to import OS, the operating system module, and we're going to get our script directory. Which tells us where our script lives, and now we're going to return that directory, our script directory, plus we're going to create another UI file called myfilter.ui. The name of your UI file does not have to be the same name as your Python script or your class, but you may find it convenient to keep track of which UI file corresponds with which filter. So now that we've defined our path in our Python script, let's go ahead and actually create our UI file. To do that, you either need to have Qt Creator or you need to get Qt Designer from the Qt website. Both Qt Creator and Qt Designer are free open source software. They're available under LGPL licenses, free for download, and so you can just go to their website and get it. To create a new UI file in Qt Creator, we're going to go to File, New File or Project, and then down here in the list of files and classes, we're going to choose Qt, and we want to pick Qt Designer Form. The Designer Form class, although similar, adds some additional C++ code that we don't need. We just want the form, and so we'll select Qt Designer Form. We will choose that, and then out of our templates that it has listed here, we want to use a widget. We don't want to create a dialog or main window or any of these other things. We just want a widget because this widget will be embedded in our extended picking dialog. So we click Next. It'll ask us what we want to call it. We already decided that we want to call this myfilter.ui. Click Next and Finish. And here's our UI layout right now. You can see that in our form area we have nothing. Because we want to filter out entities by name in selection filter, it would be useful if we had a way to input that information. So we're going to go ahead and use a simple line edit. What's called a line edit. It allows you to type in text, and since we don't need to type in blocks, one line should be sufficient. And we'll go ahead and give it a label so that when it shows up in our dialog we know what it's looking for. We'll just type in name right there. We'll adjust the size of that with this shortcut button. And then for this whole thing, we'll go ahead and put it in something called a layout so that everything is spaced nicely. And then we'll go ahead and for the overall form, we'll adjust the size again so that it's pretty small. Now the important part to remember about setting up your UI file to work with our filter Python script is that we're going to reference this particular line edit in our Python script by name. So over here, you can see we have our line edit is named line edit. I'm going to change that name to be lename so that I can find it easily when I reference it in my Python script. So I think our UI file is pretty well set up here. So we'll go ahead and we'll save our UI filter, and then we'll remember that we named our line edit lename. And we will come back to our Python script over here. So we've already told it that our UI file is going to be myfilter.ui, and indeed we named it that. Now down here in our run filter method, we've got it hard-coded in here that we're looking for hex in our entity name. Instead what we're going to do is we're going to get the text from our line edit and use that. So I'll make a variable in Python, name text equals self.get line edit value. Because it was a line edit, I know to call the get line edit value instead of the get combo box value or get radio button value or many of those other functions that are available in this class. And I need to give it the name of the line edit, so I will say le name, which gives me the text. I'm also going to put a little check in here to make sure that my line edit isn't empty, because if it is, it doesn't make sense to filter anything out. So I'm just going to do a quick Python check to say if not name text, which means that there is no text in it, it's an empty string, I'm just going to be done. I'm not going to do any more filtering. So I will return. And then down here in our for loop, instead of referencing hex, I'm going to go ahead and use name text in entity name. I will go ahead and save that file. Now if I come back to Trellis and I go to pick extended, load filters, and I select everything, you'll notice that in my filter our UI hasn't showed up yet. In order for us to get the updated Python script, because we've already loaded it once, we actually need to close Trellis and restart it. So I will close that, I will restart Trellis, I will bring back my model, I will select all of my volumes using the box select, right click, pick extended. So we'll go ahead and load all of these. My filter is still there. We'll press OK. And now if we go to my filter, you see it has our UI element there with our line edit and our name. So if I want to pick everything that has hex in it, I can come down here, do a Control-A to select everything, and we see that it lists all the entities with hex in their title. If I want to find all of the entities with nut in their title, again, I have to select everything down here, and there's everything that has nut listed. Or perhaps maybe I want to find everything that has socket in the list of entities. So I will do another search for socket and select everything, and you can see we find all of the volumes here that are named socket. Now the example filter that we made is rather simplistic. All we're doing is filtering through all of our source entities to see if they match a desired name that we're looking for. But because you have access to the Core Cubit library, you can really do complicated selection filters. We have several filters included right now, and you could certainly do ones that are more complicated. As an example, let's take a look at the radial select filter that we've implemented. If I open up our filters here, radiusfilter.py, you can see in the run filter method we actually do quite a few things to get our radius value. With the radius filter, what we're trying to do is pick an entity that is within a certain radius of another entity. And we have many options in our UI that we go through. We follow some of the basic things that we did in our simple filter where we get our source and ID types. But then we actually go through and we do some math calculations here to see if a particular entity and its center point is within the radius of our source entity. And if it is, of course, we add our target selection. So there really is no limit on what you can do here. We've exposed a lot of information about geometry and mesh through our Cubit module in Python. And of course, in Python, you can do many numerical things. You can get the NumPy library and use that as part of your filter if you want to do more extensive selection. The radial filter is one example of what you might want to do. You might want to do another filter where you're filtering out your selection list based on their x coordinate or y coordinate. You might want to filter out entities based on their actual geometric volume, how much space it takes up, or maybe you want to filter out surfaces based on surface area. There are a lot of things that this could help address. And then you can share them with your coworkers who are also using Trellis, or share them on our forum at CSimSoft so that other people can use them.